Okay, so when we're solving this, so we're integrating this, what we want to look for is, do we have the derivative of what would be the inner function in the chain rule? Do we have the derivative show up? And so this is e to the power of t cubed, right? So the inner function appears to be this t cubed, right? The outer function would be an e. This seems to be a second function, but the inner function is t cubed. So if u is t cubed, we want to look for du somewhere in there. So do we have, and again, the constant is not a big deal, but do we have this in there? And yes, we do. So the derivative of the inner function, at least in part, is in the original function that we're trying to integrate. So that means this is a candidate for U-substitution. Now, if the t wasn't there, if this was just 3 and not t squared, then we'd have an issue, okay? Because we can't manufacture a variable in U-substitution. Can't do it. But we can manufacture, in a sense, we can create just a constant multiplier. So, if that's the case, then what we're going to do is we're going to say the integral, and u is going to be t cubed. So we're going to do e to the power of u, okay? And then what's left over is t squared dt. Now I wrote dx there, out of habit, but that's actually dt. So in order to rewrite this as a du, I need 3 t squared du, or dt. So that means I need to put a 1/3 out here. I need to write a 3 inside there, because 1/3 times 3 is just 1. So now I have the complete package, and it's 1/3 here, and this is going to be e u du. Okay, everyone see that? Okay, then from here it shouldn't be a real big deal, I guess, right? Or is it, I guess? Well, what's the derivative, or sorry, the integral of e to the u? Can we do that? What's the integral of e to the u? What is it? E to the u, right. Okay, so 1/3 e to the u. Okay, so let's go with this. And plus c. Now, are we done? Does this make sense? Once we put in t cubed in there, 1/3 e to the t cubed. So if I take the derivative of this, do I get this original function back? Do we do that? So if we take the derivative of this, forget about the c, d dt of this. So I got 1/3. The derivative of e to the t cubed is just e to the t cubed. But then I have to multiply by the derivative of the inside function, which is 3t squared. 1/3 and 3 are gone. I have t squared e to the t cubed. Is that my original function that was integrated? Yeah, so we're good. So this should be, oh, I kind of erased it now. But yeah, this should be your answer there then. All right. Questions?